Okay, we end this introductory unit on hypothesis testing with something called type 1 and type 2 errors and an idea of power, the power of a test. So let's start with errors. So we need to keep in mind that when we do a hypothesis test, right, we're collecting sample data and we're checking to see if that data provides evidence to reject the null hypothesis, right? We're talking about some value, a parameter, right, from the population, whether it be a mean or proportion. And so since we can never, or not never, since it's hard to get data from everyone in the population, right, to do a census, our sample data only provides evidence, right? And so it's possible, right, based on this table here, it's possible that the null hypothesis be true, right, a value in our a parameter in our population, and we still reject it. And we say we reject the null hypothesis. That would be called a type 1 error, when the null hypothesis, right, is true, but we reject it. Now, it's possible for the null hypothesis to be false and not, right, whatever the null hypothesis is, and we reject it. That would be a correct conclusion. We reject it when it's actually false. And then think about also the fail to reject the null hypothesis. If the null hypothesis is true, right, and we fail to reject it, that's a correct conclusion also. A type 2 error occurs when the null hypothesis is false, but we fail to reject it. And that's a type 2 error. So you got to think about that, right, as we continue on. And here is the interpretation. We reject the null hypothesis, but it was actually correct. We fail to reject the null hypothesis, but it is not true. So let's take a look at the examples here and give you some context for that. And as we've talked before or mentioned, that a hypothesis test is similar to like a court case, a trial, where you say guilty and not guilty. And put it in that context, just because the jury says guilty doesn't mean the defendant's actually guilty. It's possible that he's not guilty, right? And so it would be coming up with errors, and the vice versa. You can say not guilty, but he could actually be guilty, or she could be guilty, right? And that would be an error too. And that's the how this is connected to our hypothesis test, right? We're putting a hypothesis to the test, like a court case. And so in this example, let's take a look. Here's the null and alternative. Okay, that 10% of all people write with their left hand. Now, type 1 error would be concluding, right? Go back to type 1, rejecting the null hypothesis, but it's actually correct. So we would be saying the proportion of left-handed writers is not, right, 10%, when in reality 10% actually do write with their left hand, right? This would be a type 1 error. You conclude this, in reality it's this. A type 2 error would be that the proportion, that us concluding the proportion of left-handed writers is 10%, when it's actually not, right? 10% who are left-handed writers. So again, reread that and then connect it back to our decisions, right? Because something's true in the population. We don't know it is because we just have sample data and we've only come to some level of confidence with our decision. And so that's why we could have these type 1 and type 2 errors with our decisions. And we could also be correct, right? And we want to be correct as often as possible. Example 2, the proportion here is, so looking here, we have the proportions, a defect rate of 0.01, or is it greater than 0.01? And do we have sample data to reject the null hypothesis? So let's take a look at the context of our conclusions, because we don't, okay, in a sample of a certain product found a defect rate of 0.017. Now, we're not running the whole test, we're just going through our decisions. And so type 1 is concluding the defect rate is greater than 0.01 when the defect rate is 0.1, right? That would be a type 1 error. Go back to it. And it takes time to read and, okay, type 1, reject the null hypothesis, but it's true, right? So we're saying this is not true, and this is true, but it's not, right? The hypothesis is actually true, the null hypothesis. type 2 error, right? Failed to reject the null hypothesis, but we know it's not true. Okay, we don't know, but again, in reality, and that's a type 2 error, that we say that the defect rate is 0.01 when in fact the defect rate is greater than, right? Again, that's the error of us saying, nope, it is, but in reality, right, it's greater than. And in these conditions, what would be worse in this case? Right? Think about defect rates and shipments and trying to be safe, right? So a type 2 error in this case, right, would be worse because there's actually more. If we make this error, then we're allowing more defective products to be produced, right? Because we're saying, no, the defect rate is 0.01, but in reality, it's greater. I mean, this is bad too, but again, in reality, in this context, type 2 error would be worse. Looking at another example here. Again, all these are proportions, and they don't have to be proportions. It just turns out our examples turned out to be that way. This would still work for mean values also. This is general for any hypothesis test. Null hypothesis is 52% of graduate students attend SAC. We think that this estimate's wrong, so it's not equal to 0.52. Right? What is a type 1 error in this context? Type 1 is to reject the null hypothesis when it is true. So it's concluding that the proportion of graduates who attend SAC is not 52% when it actually is 52%. That would be a type 1 error. Again, read, think about that. And then lastly is the power of a test. You can read what the power is, the probability of rejecting, right? The probability of correctly rejecting a false null hypothesis, complement of a type 2 error, right? This is what we call the power of a test. It depends on the true value of our parameter, which is often unknown, we don't know. But the more powerful our test, the better, okay? The better our test. In order to increase the power of a test, we wish to make it. So we talk about these hypothesis tests as in terms of its power. How much power does it have? Right? And it's the probability of correctly rejecting a false null hypothesis. Again, think about the wording. The probability of correctly rejecting a false null hypothesis. To say reject the null hypothesis when it actually needs to be rejected. Okay, with the correct decision there. So in order to increase the power of tests, right, which is easier to reject null, there are two ways to do this. You increase the sample size, that will help. And then secondly, you increase alpha. Oh, there should be an E there. Increase alpha. If you increase your alpha, then you're more likely to reject a null hypothesis. Okay, it's easier to, again, we have to put this in context. It's just a big idea that we have in statistics regarding hypothesis test.